Hi, everyone. Wow, this is such a huge room. Thank you so much for being here today. And thank you so much to WeAreDevelopers for bringing me all the way out to Berlin. My name is Shirley, and I'm an independent creator of data visualizations. I started out as a software engineer back in 2012 at a big data company, where I first learned the JavaScript library D3, and I learned how to create data visualizations with them. And I love that so much that for my second role, I decided to take a front-end dev position working for a data visualization product. And in 2016, I decided to take the leap, quit my full-time job, and try my hand at freelancing, only doing data visualization projects. And for the last 3 years, I've had the great pleasure of working with a variety of clients, mostly across the tech, media, and journalism industries, helping them tell visual stories with their data, as well as a personal project called Data Sketches with my great friend Nadi Bremer, where we create 12 different data visualizations on topics of our choosing and write about our process from start to finish. And today, I want to share with you some of those past projects over the last 3 years. But more importantly, I want to share with you the many, many lessons that I've learned creating those projects across the whole data, design, and code process. So let's get started. When we start any data visualization project, the very first thing, of course, is to go out and get that data. And through the years, I've found that, at least for my own projects, it's very important for me to start out with a curiosity, a topic that I'm so interested in that that curiosity will motivate me throughout the whole project. And I've also found that with that curiosity, I can really get creative with my data gathering to answer my questions and satisfy that curiosity. Sometime in the middle of 2016, I was really, really obsessed, very obsessed, with this one musical called Hamilton. I don't know if anybody in the audience has heard of it. It's a very, yes, thank you. It's a very American musical. But I was so obsessed with it that I listened to it on repeat for months on end. And it got so bad that I was like analyzing all the lyrics, and my fiance was like, why don't you just make a data visualization about it? So this is an interactive visualization of every line in Hamilton, where each of these dots represent a set of lyrics sung by a character in the musical. And as the reader scrolls, I present them with all the analysis that I've done and all the insights and interesting patterns that I've found, until they get to the very end, and I share with them the exploratory tool that I use to do my own analysis, where they can filter by any set of characters, conversations, and themes, and dig into all of the remaining lines and songs to do their own analysis. And this project really started because I had this curiosity, two curiosities actually. And the first question was, how do the relationships change between these characters throughout the musicals? And two, what recurring phrases are there, and who are they associated with? And you can probably imagine that none of this data is available out there anywhere, at least digitally. So I had to go through all of the lyrics of the musical by hand, noting any of the recurring phrases and any variations on those phrases, grouping all of those phrases into broad themes, and then manually going through the lyrics again, entering them into the computer, and noting any characters and conversations. And then I wrote a script to aggregate all of that metadata by song and line number to get my final data set. And this project, along with many similar ones, have taught me that as long as I have a curiosity, I can go out and find the data I need to answer all of my questions, whether it's through manual entry or automated scripts, as long as I stay within the boundaries of the law. Now that we have our data, the very second thing I've learned to do is to always explore that data before starting on the design. This is a project I did for Data Sketches called 4 Years of Vacations in 20,000 Colors, where I took 4,000 images over the course of 13 trips, pulled out the 5 most common colors in each of those photos, grouped those colors by the trip that they were taken on, and then arranged those colors by the day of the trip that they were taken on. And this project is one of my personal favorites because I learned a lot about myself through this project, which is that I've always known that when I'm on vacation, I really like taking pictures of nature. So all the waters, the lakes, the oceans, the mountains, the trees, and all of these greens and blues made a lot of sense to me once I saw the visualization. But I was really confused as to why I had all those reds and oranges. And when I took a look at the underlying photos, it turns out they were all food photos. So it turns out this trip to Japan back in 2014, apparently all we did was eat. And then this one was to Iceland, so there was quite a few beautiful lakes and glaciers. So yeah, this is one of my favorite projects, personal projects. But the project didn't actually start out so well. This is one of my first very rough sketches once I had collected my once I had collected my data. And I had really good intentions. I really did. I wanted to understand where and when I was taking my pictures. So on the x-axis, I have the time of day that the pictures were taken on. And then I extended that, and I kind of wanted to see which continents maybe I was taking the pictures on. And on the y-axis, I wanted to map the year that the pictures were taken on. I had really good intentions. But what happened was I had collected all of my data, and it took so long. I was so exhausted. I was like, I don't want to look at the data anymore. So I had zero understanding of what my actual data was, zero understanding before I started sketching this design. And so when I actually went to the code part and executed this design and put my data onto the screen, this is what happened. I'm now quite fond of this piece. I now lovingly call it my art piece. I call it a man peeing into puddle. Yeah, I've grown attached to it. But it's not a data visualization piece that I could have published, so I went back to the drawing board, I took a step back, and I asked myself, okay, I really need to understand my data. So what metadata do I have? What metadata does each photo, each data point have? And I saw that I had the data of the trip that each of these photos was taken on. And so I thought maybe I can group each of these colors by the trip. I had the day that it was taken on, so I decided to map the date to the angle so that the colors were kind of arranged around the circle, the group, the trip. And then because they're colors, I, of course, had information on the hue, saturation, and lightness. So I decided to map the hue to the radius so that for each of the trips, I had a gradient from yellow to blue back to red. And this project really, really taught me that I need to explore my data before I start on the design, to list out all of my data attributes so that I can assign them to the correct visual channels, so that I can list out my quantitative data attributes and assign them to visual channels like XY position, width, height, angle, radius. And for my categorical data attributes, I can assign them to visual channels like colors and shapes. And to always, always watch out for extremes and watch out for outliers. But I've also learned over the years that creating compelling data visualizations take more than just assigning the right data attributes to the right visual channels. And in fact, I've noticed that creating some of the most compelling and best data visualizations I've seen masterfully use visual metaphors. Like when the New York Times decided to visualize class mobility as dots on the screen literally animating up or dropping down, or any number of visualizations that decided to use red dripping bars to convey an underlying data set about murders or deaths. And I firmly believe that it is these subtle uses of visual metaphor that help our readers understand what the underlying data set is and decrease the barrier to understanding more complex visualizations. And in a world where our readers are constantly bombarded with thousands of things on their screens vying for our attention, I've learned that it's really important to design to maximize for delight, to include subtle little, sometimes maybe even flashy little details that will motivate them to keep scrolling through the story. In 2017, I got to work with my friend Nadi Bremer on this piece for the US Guardian called Bust Out, about how American cities move their homeless. The Guardian team was able to obtain data from 16 different cities, totaling to more than 20,000 trips, journeys that homeless people have taken across about 7 years. And they did an amazing, amazing piece of investigative journalism that looked into all of the policies behind this homeless relocation program. They looked into the cities that not only buy bus tickets for their homeless, but also flights, into the economic situations of these cities, into the relatives and acquaintances that receive the homeless people on the other side, and at the potentially financial incentives that cities might have for this program, including how in San Francisco, over the course of 10 years, if these people had not been bussed out, the city would have been responsible for almost double the homeless population. And it was a very important and meaningful project that got a lot of attention and cited policy talks. And Nadi and I got to create a variety of visualizations for them to help tell the story. But today I want to concentrate on just one of those visualizations, the one about New York City. New York City is quite a unique case in that it's the only American city that buys not only bus tickets for their homeless people, but also flight tickets, plane tickets to help them get to their destination. And to convey this, we had two main goals. The first, to highlight the furthest flights New York City had bought for their homeless people. And second, to show the most frequent destinations. And to accomplish the first goal of highlighting the furthest flights, the very first thought we had was to use a map. But we didn't want to use a map, not only because we had just used a map to introduce our data set, but because maps are just inherently bad at showing relative distances between different starting and ending points. And so the next thought was a bar chart, because bar charts are made specifically to show relative differences, relative quantitative differences. But we wanted to give our readers something a little bit more than that. And so we decided on this visual metaphor of flights taking off and flying across the screen in an arc and landing on the other side at their destination. And from there, it was quite straightforward to expand on that metaphor to accomplish our second goal of showing the most frequent destinations by representing people as dots that followed the arc across and landing at their destination. But even then, it took many, many iterations, this only being a subset, to get the animation to a satisfying point where we hoped they incited enough delight, but did not slow down the readers reading through the story. And so this is the final visualization where each arc represents a destination and each dot grows in size as more and more people fly there. So far, we've talked a lot about the data gathering and the design parts. But now I want to talk about the code part, the part that we as developers are all the best at. And in the last year or so, I've started joking around that data visualizations are basically just SVG paths and trigonometry. But I think it's actually quite true, because data visualizations on the web is all about drawing shapes onto the screen. And I've learned that one of the best things I've done for myself is to teach myself SVG paths, because with that under my belt, I've found that I can draw really any shape onto the screen that I can imagine up in my head. This is another project I did for data sketches called Film Flowers, where I reimagined the top summer blockbusters as flowers, where each of the different petals represent parental guidance ratings, the different colors represent the genres, and the number and size of the petals are their IMDb ratings out of 10. And so there are some, I think, really beautiful ones in here, like The Dark Knight Rises and Inception. My personal favorite will always be Harry Potter. But the one that I love showing absolutely love showing every single time is the 1997 Batman and Robin, because of how small and cute it is. And when I first published this project, I got a few questions about how I did it, if it was hard. And the answer is that it's actually quite straightforward. And all it takes is an understanding of SVG paths, and in particular, the cubic Bezier curve command. And so I want to show you how to create the cherry blossom flower. And so we start out with one of the petals and drawing this curve. And the way that I like to think about drawing this curve is that I start out with a starting point, in this case 0, 0, and I draw a straight line down to my ending point, the purple point. And I take those two green and blue anchor points, and I drag those out until I get the curve that I want. I draw two straight lines, draw another curve on the other side, draw 5 more petals, rotate them around, and fill them with color. And that's all the code to draw that shape. But just drawing shapes onto the screen doesn't make for a data visualization. And data visualization, to create data visualizations, we need to be able to translate raw data into screen space. And to do that, we need the help of some JavaScript libraries. And while I think that D3 is the definitive JavaScript library for creating data visualizations on the web, I think there are subsets of D3 that other JavaScript libraries do better. And over the years of experimentation with different libraries, I've come to find that I really like combining D3 with Vue and Greenstock for the most efficient coding. And to show you what I mean, I want to create this demo visualization with you. This is a visualization of the top blockbusters in the last decade. And there's 2 parts to this visualization. There's the histograms at the bottom that are showing the spread of Metascores and box office figures. And then there's this kind of semi-custom part up there where each of these little curves represent one of the movies. And the x-axis is their release date, and the y-axis is each movie rises up if its box office figure is above the median box office figure, and the movie drips down if its box office is lower. And there's another interaction in here where I can filter those movies by their Metascore and box office figure. So let's say, for example, I'm interested in seeing all of the movies that did less than the median in the box office, but scored quite well. And that's WALL-E and The Martian and Inside Out. And then let's say, on the other hand, I want to see all of the movies that did better than the median in the box office, but did horribly in the scores. And that's Transformers and Transformers and Suicide Squad. But today, I want to code this with you. So this is the live code portion of the talk. And please be nice to me as I do this. So for this particular visualization, I've already gotten the histogram part. I've done that beforehand, and I want to create I've been calling it the area chart, the custom part up above. And I want to do that with you. So let's get started. This is my app component, my view component, my root view component. And all I'm doing here is going in and fetching my movies data set, and then registering that movies data set with my view component to keep track of any changes in that data. And then I have a template where I am rendering my area chart and my histograms. And for my area chart component, I'm passing down that movies data. And within the area chart, I am receiving the movies data and then watching for any changes in the movies data set and I am calculating the scales, and I'm calculating the data. And so let's do this part together. So like I mentioned before, creating data visualizations is all about translating raw data into screen space, and D3 helps us with that. And the three things that I want to translate are the X position, the Y position, and the color. And for the X position, what I want to do is translate the release date of movies into the X. So let's go and get the minimum release date and maximum release date using D3. And I pass in my movies data set, and I tell it that I want to use a release date. And then let's create a D3 scale with that. And then I'm using a scale time. And D3 scale time, what it does is it takes as input a JavaScript date object and outputs a continuous range. And so what I want to tell it is that the min and max input I want is 2 months before the minimum release date and 2 months after the maximum release date. And I want to map that to I want to map my minimum to the left side of my screen and the maximum date to the right side of my screen. So the width of the visualization, and then give it some margin. And then to calculate the Y scale, I want to first get my median box office because that will be my baseline. So let's do that. So I'm passing in my movies data set yet again, and I say I want to get the median of the box office figure. And then I want to go and get the minimum and maximum box office figure. And I need to remember to get the box office figure, subtract that by the median box office. And then let's create a scale for our Y position. Let's, this time around, use a linear scale that will map from a continuous input to a continuous output. Pass in the box office figure, and then let's map the minimum box office figure to the bottom of our visualization. So that should be the height of our visualization minus a little bit of margin, and our maximum box office figure to the top of our visualization, so margin.top. And let's just go and calculate the Y position for our median box office figure, the baseline. And then let's go and get our color. So let's go and get the minimum and maximum Metascore and use that as our colors. And this time, I'm going to say I want to use the score. And I'm going to create a color scale using D3 sequential, which maps a continuous input to a sequential output. And I'm going to use a color scale called interpolate varieties. I'm going to tell it that I want to use my minimum maximum score as our input. And then I'm going to use a D3 area generator. And what D3 area generators do is that when we pass in a series of points to D3, D3 goes and draws a line through all of those points, and then it fills it in to the baseline. So let's tell D3 our baseline, and then let's tell it what kind of curve interpolator we want it to have. OK, so this is all the setup, and then this is the satisfying point. Let's go in and use all of that to translate our data. So let's go through all of our raw movies data set and let's just get our ID. And then let's have D3 calculate our SVG path for us. So to do that, we need the area generator that we just created. And like I said, the area generator takes an array of points. And to draw the curve of a movie, we need 3 points. The first at the baseline 2 months before the release date, the second at the Y position of the box office figure, and the third back at the baseline 2 months after. And so let's do that. So let's go and get the X position of 2 months before the release date and the baseline. Then the X position of the release date itself. And then the Y position of the box office figure minus that median. And finally, the X and Y positions for the last point. And then let's go and get our color. And for the color, we want to translate the score. So let's pass in the score for the movie into the color scale. And if I've done all of that correctly, once I console log, we should be able to see something. So let's see that. Let's get it bigger. And there it is. There's 98 movies, and for each movie, I have the fill color and this really long SVG path string. OK, so now that we have this, let's go and actually draw that onto the screen. And to do that in View, I go up to the View template, and I just say I want an SVG path. And I want one for every single arc that we just calculated. And the path string I want to use. And let's fill it with the color that we calculated. And then let's give it a white stroke so that we can tell overlapping ones. And then we're just going to give it an identifier of d.id. And this is the line that I'm most excited about with View and D3 together, because if you've ever used D3, you know that this one line replaces the dozens of lines that D3 does with enter, update, exit. And so in this one line, it replaces a dozen lines. And so now that I have this, if I just refresh, I have that. And I have a bug because the colors are not right. So let me just go back and do that really quickly. D3.scale min. Oh, it's because I used the wrong min and max. So I want the min and max score. And now there we go. Thank you. So as you can see, quite a little bit of D3 setup, and then View does the rendering in just one line. And now I want to show you that interaction from before, where you can brush these histograms and filter. And that interaction might look like it's really fancy and might take a lot of code, but it really doesn't. And so I want to show you how to do it. And to do that, let's go into our histogram component. And I have this SVG group element, and I've just given it a reference called brush. And once the component mounts, I have a D3 brush instance where I just tell it to, then I just want to use D3 to select that group element, that SVG group element, and then call the brush, the D3 brush instance, and then this one line, D3 goes and creates a bunch of DOM elements to do this interaction and handles all of the events. But you might have noticed that we might have this kind of brush interaction, but none of the filtering is happening. And that's because we have to hook up the filtering ourselves. So let's go do that. So on the brush instance, I say that on the interaction of brushing, I want to call this function called brushEnd. And in brushEnd, what I want to do is go and get the bounds. So when I brush over, what D3 does is remembers the x positions of the left and right bounds. So let's go and get that. D3.event.selection. And then I want to translate that x position back into my data. And to do that, all I have to do is say this.xscale.invert, pass in the x position, and then do that again. x2. And then I want to pass that up to my parent app component. And I just want to tell it which histogram is being brushed on, and then those bounds. And then if I've done that correctly, I can go back up to my app component, to my update filters function, console log. And I should be able to see, once I do this, ooh, D is not defined. D3.event. This.id. And so now, if I've done it correctly, then hopefully I see in console log, there we go, that I'm brushing over the score histogram, and I have got the brush between 67 and 100. Now we have that. We have to go and register. Let's go and remember that filter in our overall set of filters. And then this is the kind of the most complicated part, which is that I want to go and filter down my original movies data set to just those movies that fall within those filter bounds. So let's go and do that. And so the logic there is that I want to go through my movies, and for every filter, I only want the movies that either there is nothing being filtered or falls within the two bounds. So hopefully I've done that correctly. Console log that. And if I've done that correctly, then the array I get back should be less than 98. Let's see. OK, yes. All right, so you can see that the histograms are being filtered correctly, but I just need to hook up the area chart above. So let's go back into the area chart. And what we want to do is we're also getting that filtered data set from our parent. Let's watch for any changes there. And if it changes, let's just only go and recalculate those arcs. And within calculate data, instead of using the original movies data set, let's use the filtered data set. And there we go. Those are the steps. Thank you. And let's add in that one last little finishing touch, which is that you might notice all of those curves are just popping in, but let them animate in smoothly. In Vue, animations are a first-class component, so we just need to use a built-in transition group, and we tell it that we have, for on enter and leave, we have these functions we want it to call. And we use GreenSock and animation library to, on enter, have the curves grow up, animate up, and on leave, have those curves animate down. And with those three parts, they now smoothly animate up so that it feels really nice. So the way that I like to think about it is that I like to use D3 for scales and shapes so that I can translate the data, raw data, into screen space. And I also like to use D3 when I need to use things like axes and brushes that are very common data visualization patterns that D3 implements better than any other library. And I like to use View for its reactivity system to replace D3's enter, update, exit pattern and the dispatch system so that it's much easier with View to handle interactivity between different parts of the screen. And finally, I like to use Greenstock in an animation library, and in particular, Tween with View to replace D3's transition, and Timeline for more complex multi-step animations. And all of this, I found, leads to much fewer lines of code and faster development in my own projects. So if you've liked any of the things that you've seen, I have many more talks and workshops that expand on different parts of the things that I've covered today. And thank you so much for listening.